Hi, in this lecture we are going to talk about the getItem method. So we will have the def get with the self and the key, of course, because we would like to return the values according to keys. So we just say that the node is equals to the self.getItem, the self root node, the key, and we start with index 0. And if the node is equals to none, we are going to return, for example, -1, which means that the given key is not present in the dictionary. Anyways, we return the node dot value. Okay, it's going to be just fine. So we would like to define another method. Okay, def getItem with the self, with a node, with a key, and with an index. Of course, without the value, because we are looking for the value, so that's why the value is not going to be present as far as the arguments are concerned. If the node is equal to none, we are just going to return none. Okay. Anyways, we get the C again as the key with the index, and we basically do approximately the same. If the C is smaller than the node character, we know we have to go to the left. So we return the self getItem with the node, left node, the key, and the index. We are not going to increment the index. And if the C is greater than the node character, we know we have to return the self getItem. We call this method in a recursive manner, but of course the right node, the key, and the index. Else, if we know that the C is equals to the node.character, because it's not smaller and not greater, so the C is equals to the node.character and the index is smaller than the key. Sorry for that, len of the key -1. It means that we are not at the last character of the key. We return and we go to the middle child. So we call this method recursively as far as the middle node is concerned, the key, and we keep incrementing the index. It's very important. Okay. And else we know that we are standing at the node that we are looking for. So we're just going to return the given node. Okay, this is exactly what we are looking for. So let's see whether it's working fine. We will have the def name is equals to the main method. This is how we start our application. First of all, we instantiate a new ternary search tree like this. We put, for example, apple and the 100. We put another item, for example, the orange, and for example, 200. And I would like to print out the tst.get. I would like to get the value where the key is equals to apple. Okay, let's save it. I guess there's not going to be any errors, but let's take a look at it. Of course. So what's the problem? Line 17. Oh, sorry for that. We don't need that. Okay. Sorry. Let's try to run it. Of course, another error. Oh, I forget line 58. Okay, there may be several typos. Of course, we need something like this. Let's try again. Of course, because not def, but if. Sorry for that, but I guess it's going to be the last error. Okay, as you can see, we get the 100 because the 100 is associated with the key apple. So if we want to get the value associated with the key apple, then 100 is going to be returned. If the key is Adam, of course it is missing from the dictionary. We should get -1. This is how we defined our algorithm. If the node is none, then we return -1. If the key value pair is not present in the dictionary, the result will be -1. Let's see, for example, orange, we should get, of course, 200. So clear the console and let's run it again. Yeah, it's going to return 200. So as you can see, it's working fine, and it's going to be a bit better for search misses, because ternary search trees are not going to examine all the characters as far as the key is concerned if there is a mismatch. Of course, when we create a hash function, for example, for a dictionary, I mean as hash tables are concerned, the hash function is going to examine every single character of the key. So that's why for search misses, ternary search trees are a bit better choice. Thanks for watching.